For many more than thousands of years, we've watched birds fly through the sky and probably been jealous that we couldn't soar into the skies as well. You know, humans are bound to the earth, and aeroplanes and drones are our attempts at emulating nature in that way. It's just a testament to human ingenuity, I think.
Very close.
Yeah, it's not quite.
Yeah, we need to make a space bell.
Yeah. Oh my god. The act of making something fly is something that's so mind-boggling to the human race, and that's why it has such a passionate crew behind it. Monash UAS, we have 3 pillars that we're based around. First one is to demonstrate the positive impact of drone technology, and second and third kind of go hand in hand, but it's to inspire and educate the next generation of engineers, to kind of push them into engineering streams to kind of foster that kindling of innovation within them.
We really try and upskill our members wherever we can, and if we see an opportunity to do things better, even though it might be a little harder at first, we really try and grab that opportunity. I think the humanitarian side of UAS is one of the things that sets us apart from other student teams.
There is quite a stigma or quite a precedent for some of the negative impacts of drones, and I think as a team we really want to show how much good you can do with drone technology. Especially here in Australia, we have such wide open expanses of outback and regional towns which are separated by great distances, and in situations and areas like that there's huge potential for drones to do medical aid delivery or search and rescue or something like that, and save on resources that would be put towards a traditional aircraft.
Yeah, I guess Albatross, our biggest reason for naming it was because of its size. It's actually got over a 3-meter wingspan, which is actually the same as an Albatross, so that was actually the main inspiration behind it. We are currently putting it back together because this aircraft did have a pretty serious crash about a month ago, so far it's been going pretty good. Shortly after liftoff, our aircraft pitched forwards in a kind of uncontrollable manner. The nose hit the ground first, which caused it to kind of tilt, and then one of our wings caught the ground. And that wing catching the ground at speed kind of broke one of the internal spars. We've gotten the wing physically repaired, now we're just wiring it up again today. As we refined our design, the horizon was, I guess, showing what we're capable of, showing that our drone technology is pretty much on the horizon.
Traditionally, you look at the horizon and you think, this is the end, that's all there is, that's all I can see. But there's so much more untapped past there that we can go through and explore through something like Albatross V3 Horizon.
Search and rescue is definitely been the main focus of our Albatross aircraft. In a circumstance where we might have a person in an outback or a really hard to reach place and they're in need of really quick assistance, it's a lot faster and safer to send a drone there rather than setting up a helicopter and organizing personnel to go fly that helicopter to someone.
That involves flying autonomously and detecting a patient in need on the ground, and then lowering them some medical supplies completely autonomously.
It definitely is a nice little segue from meshing the highly technical aspects of engineering with the needs of a community, really.
This is why you use 0805, not 603.
So it's slightly bigger,
Yeah.
and you don't have to, like, bodge fixes are a little bit easier with the larger components. For some of the components in the aircraft that are a little bit more simple, we have sourced off the shelf. But there are some more specialized components such as the power distribution board where we want to custom design these parts to our needs and get extremely specialized solutions for our problems in the aircraft.
For the past, I believe, 7 years, we've been using Altium almost solely for all of our electrical designs.
Altium was my first tool in PCB design, and obviously at first there's a bit of a learning curve, but I found there was quite a lot of resources online. Even some of the things that confused me at first, for example, making custom footprints, I found that to be quite an easy process to pick up and actually very intuitive once you've actually got some experience designing boards.
We have students of various different skill levels and experience levels coming onto the team. So having features like being able to comment and the version control allows us to work together and learn from each other in some ways on these projects.
One of the things I was particularly proud of was achieving a 5-volt regulator for the first time. I've read online and I've also heard from some of my colleagues within UAS that regulator design can be quite fickle. When we first soldered the board and then powered it on, and I probed the test point and I saw 5 volts coming through the multimeter, I was very proud in that moment.
Passion has definitely been the main driver of progress for aviation in general. You know, we had the Wright brothers who actually, got their first working aircraft, and from there, within a century, now we're going into drone technology, which is again a brand new field of technology, and already it's making leaps and bounds, in reliability, in efficiency.
Humans always want to go one step further, and there's kind of that innate desire to push the boundary. Suddenly, something like the identification of oil spills could easily be something we extend our drone to. We already have a camera on the drone with a gimbal running an artificial network to detect humans. It wouldn't be too much extra effort to retrain that model for something like detecting those oil spills, or even something like bushfire detection. And you could even amplify that by adding an infrared camera to detect the heat from the bushfire. And then suddenly you can see, like through a forest canopy, for example, that a fire is starting beneath without even being able to see it visually. It's something that I hope as a species we continue doing, is to see how much further can this go. Being able to be there at the forefront and be a pioneer in this kind of field is such an exciting proposition.
We're still at the start of this field, and it's going to be our generation of engineers who really take it to that next level of really making it the best it can be. And when you discover that something can be done, it kind of makes everyone flock to the idea, and that's where you get the main driver of progression as well.